So we're continuing our discussion about using ratios, rates, and proportions. It's going to lead us to be able to work with similar triangles and similar polygons starting the next section. This is just another review section. I think you've covered most of it before, but just to make sure we've got this idea of ratios, rate, and proportions down before we move on. So let's say I've got a photo, and again, just like the previous one, I'm going to enlarge it proportionally. This should say proportionally here, because enlarge could be like, this way, that way, a little bit too much. But enlarge, let's assume proportionally. Okay, and so it is 8 inches wide, 8 inches wide, and 5 1/3 inches high, 5 1/3 inches high. And it's going to be enlarged proportionally so that it is 2 feet wide. So 2 feet, the single tick means feet, and 1 1/3 feet high. What is the ratio of the width of the photo to the width of the poster? Okay, so width would be the longer side. That would be this to this. So we can make a ratio. Now again, a ratio is comparison of this to that, A to B, but again, a ratio means that the units are the same, or there's no units because they can just be canceled out. Remember, a rate is when the units are different. So if I try to say the ratio of the photo to the poster, if I just try to say, 8 inches to 2 feet, that's incorrect. That I guess you'd call that a rate. That's not a ratio, right? So we have to convert. We have to convert feet into inches. Let me just write this so it's a little more clear. Feet into inches, or I guess inches into feet, but it's probably easier to convert feet into inches. Now you could probably do this in your head, but let me just show you how you're going to do this in the future, probably in chemistry and things like that. When you want to convert from something to something else, you have to have a conversion factor, and in our case we know that 1 foot equals 12 inches, right? 1 foot equals 12 inches, so this is the exact same as this. That means I could write 1 foot over 12 inches, right? This is the same as this, and what is that? It's really just the number 1, right? It's the number 1, this pen here, because they're the same, right? Same on top, same on bottom. Likewise, I could also write 12 inches over 1 foot, right? Because 12 inches is 1 foot, so it's the same thing over itself. This is also 1. So you could write either way. You want to just write it, pick the one that cancels out what you need to cancel out. So what do I mean by that? So I want to convert 2 feet to inches. Okay, and I know you can probably do this in your head, but let me just show you how it works. So 2 feet, I want to convert into inches. So basically, I want to multiply 2 feet by an equivalent form of 1. Right? 1 is going to go here. Why? Because when you multiply by 1, you're not changing the number at all. Okay, I'm going to multiply by 1. So I can either pick this way or this way. I want to pick the way that, because feet is in the numerator up here, I want to put feet in the denominator here. So I want to pick this version. So 1 foot, 12 inches. Okay? Again, this is just an equivalent form of 1. If I pick this one with the inches in the bottom, it wouldn't have canceled out. But now I've got feet over feet, which is just 1. It just crosses off. And so I'm left with 2 times 12, which is 24 inches, right? That's the one that's remaining. And you knew that, but this just goes to show whenever you want to convert something to something else, you find the conversion factor and you either arrange it like this or like this, whichever way is going to cancel out the one you want to cancel out, and then you just multiply straight across. So instead of 2 feet, I'm going to use 24 inches, right? So instead of writing 2 feet, I'm going to write 8 inches over 24 inches, right? Inches over inches, this is a ratio. We can actually just cross this off because we don't need units at all. And because we like them to be simplified, we want to divide them both by something. 2 works, 4 works, but you know what? 8 works even better. So I'm going to divide. Again, I can divide by an equivalent form of 1 as well. So I get 8 divided by 8 is 1. 24 divided by 8 is 3. So my ratio of the width of this to the width of this is 1 to 3. You can also write it as 1 to 3. Right, this is 3 times bigger than this. Okay, let's go ahead and solve the proportion. So again, proportion we talked about last time. It's just saying that this ratio is the same as this ratio, or it could be a rate, right? This to this is the same as this to this. It's our key for coming up in this chapter. The method we learned is cross multiplying. So instead of multiplying both sides by 8 and then multiplying both sides by 4, it's just a little bit faster to just kind of go like this and we're going to get 8y equals, now the key for this one is that you put it in parentheses, 4 times the quantity y plus 3. So I'm going to distribute and make sure I don't forget that. So we get 4y plus 12. Okay, I've got y's on both sides, so I'm going to subtract 4y from both sides. It's going to be 0 over here. So I'm left with 4y equals 12. I divide both sides by 4, I get y equals 3. The great thing about proportions is I could check it, plug it in here. 3 plus 3 is 6 over 8. Question mark, does that equal 3/4? Does 6 over 8 equal 3 over 4? And if I divide this by 2 over 2, then yes, it does work, so I know this is correct. Okay, so using proportions properly. Okay, moving on. In a scale drawing, so we've seen, or we will see things blown up or shrunk down. If we're reading a map, oftentimes we get a scale going. So let's say I've got this thing where 1 inch equals 16 feet. Just want to practice using this again. So I want to use a ruler to measure this length here. What is the length of the actual bedroom? I printed this out. I'm not sure if it's exactly accurate. I hope it is. Let's see what we have here. We have got 1 inch, and again, these are not tenths. There's 1, 2, 3, 4, 5, 6, 7, 8. So each one of these ticks represents an eighth. So I've got 1, 2, 3. This is 1 3/8 of an inch. Right? 1 3/8 of an inch. 1 3/8 inches. Okay. So what is the actual bedroom? So it's the same thing. Just like above, we can say that in this problem, 1 inch equals 16 feet. It's kind of a weird idea, but what this means is I could write 1 inch over 16 feet, or I could write 16 feet over 1 inch, kind of just depending on which one I need to use to convert here. So I've got 1 3/8 of an inch here. So let's start with that. 1 3/8 of an inch, and I want to convert that to feet. Oops, an inch. So I want to multiply by either this or this. I want to multiply by the one. This is the equivalent form of 1 here that's going to cancel out. So I'm going to put it over inches. So 1 inch, 16 feet, right? Because then I get inches over inches. And of course, you could just do this in your head. I mean, it's kind of easy scale where 1 inch equals 16 feet. So I've got a little bit more than 1. So I'm going to multiply by 16. I'm just showing you how that works, right? Because when you arrange it like this, you get inches over inches, and that's gone. And so you can just take 1 3/8 times 16 feet. This thing is freaking out, so I'm going to pause it. So now what's left is to multiply 1 3/8 times 16. I could convert this to an improper fraction by multiplying. 8 times 1 is 8, plus 3 is 11. So I could change this into 11/8 times 16 over 1. Or I could just do it on my calculator. So I can just take 1 3/8, which would be, so 3 divided by 8 is 0.375. So 1 3/8 would be 1.375 multiplied by 16, and I get 22. 22. Right? The inches crossed off, so I'm left with 22 feet. Right, you would see that this worked as well. 16 divided by 8, I could reduce that to being 2 over 1, and you can see that this is also going to give you 22 feet. So it doesn't really matter. All right, so scales, right? We can use 1 inch to 16 feet, 16 feet to 1 inch. In this problem only, right, it kind of counts like an equivalent form of 1, right? Because they're equal to each other in this scale. You want to arrange it so this cancels out. All right, so moving on to the next page. This time we don't have to measure, but same thing. This sandwich shop shown is a giant milk bottle, and it is 40 feet tall. Okay, go ahead and see if you can pause the video and solve the rest of the problem. Okay, a hint is coming. So the shop is an enlargement of an actual milk bottle. I don't know what the actual milk bottle looks like, but let's say it's this. I want to find this. Okay, scale used in construction. So I took it and I blew it up proportionally using this scale. 5 feet equals 2 centimeters. So again, I could I'm going to find this starting from this 40 feet. I'm going to take this 40 feet and change it back into, all right, how much was this if this was the scale? All right, it's a little bit harder because it's not 1 or anything like that. So we're going to multiply by an equivalent form of, well, kind of 1 here in this case because they're equal to each other. So if you haven't finished yet, go ahead and pause and see if you can figure out how to finish this problem. Okay, so in our case, do we want to use 5 feet over 2 centimeters or 2 feet over 5 centimeters? So if I did 5 feet over 2 centimeters, notice that the feet and centimeters would not cancel out, and that would not work. So I'm not going to put 5 over 2 here. Notice if I put 2 centimeters over 5 feet here, right, what happens is I get feet over feet, and that is going to become the equivalent form of 1 and crosses off nicely. So what I have then is I'm left with centimeters, and I can just multiply straight across, or I could divide 40 by 5, either way. I could multiply 40 times 2, which is 80 over 5 centimeters. Okay, 80 over 5 centimeters. Or another way is you could say, hey, 40 divided by 5, 40 divided by 5, I know that that's 8 over 1. And then you're left with just 8 times 2, which is 16, right? 5 goes into 80 16 times. So 16 centimeters is the original height. Okay, so we've been doing a lot of work with proportions, rates, and ratios. We're going to be moving more into using triangles in these. So we haven't talked about similar polygons yet, but this is kind of the idea we'll be doing here. So given this to this equals this to this, find CT, right? This is a proportion, right? This is a proportion, again, saying that this ratio is the same as this ratio. So for now, we're just having to plug it in, but let's see if we can do that. So SB, so I know, given SB, which is 35, over BU, all right, now BU is not given to us, but we know that this is 42, so if the whole thing is 42, this is 35, this has to be the remaining piece, right? So I could just take 42 minus 35, and that gives me 7. 7 is the same as SC is to CT. So SC is 45. Let's find CT. You can call it X, you can call it CT, whatever. And again, we have a proportion. This to this equals this to this. I can multiply both sides by 7 and then multiply both sides by X. But because we have a proportion, it's just one step faster to just cross multiply. Now, before you cross multiply though, there is a technique we can use, which is to simplify, right? This is just a ratio. It's probably in our best interest to simplify this. Look at how much easier that is. 35 divided by 7. If I divide numerator and denominator by 7, well, 35 divided by 7 would just give me 5. 7 divided by 7 would just give me 1. Oh, that's so much easier, right? Instead of doing this using these big numbers, I've got this. I can just cross multiply, and I've got 5x equals 45. 5x equals 45, divide both sides by 5, and I get x equals 45 divided by 5, or x equals 9, so CT equals 9. Okay. If I'd use these large numbers, I'd have to do 45 times 7, right? 45 times 7, which is 315, and then divide that by 5, which, oh, sorry, divide that by divide that by 35, excuse me. Divide by 35, which would be 9, right? But that's a lot more work. Okay, so why don't you go ahead and pause the video. Last problem, go ahead and see if you can do it on your own. Given that proportion, this to this equals this to this, find JE. Okay, I'm going to call this X. So CE, see if you can figure this out. What would I call CE? CE. If this is 21 and this is X, what would I call CE? Well, that would be this combined with this, right? This combined with this. Combining things together means you're adding together. So it would be 21 plus X. 21 plus X over CJ, which is 21, equals CD. And that would be this 64 here. over CK, and this is not given to us, but we can figure it out because this is 64. This is 40. This is kind of, I know this is odd. It should be out of scale because this is the longer one, but whatever. So 64, this is 40, so I have to take this away. So 64 minus 40, that would give me 24. So this is actually 24. I know that's a weird scale. This should be shorter than this, but it's computer generated, so whatever. Okay, so if you got stuck, there you go. Go ahead and see if you can solve the rest by hand. You might want to simplify this, especially if you don't have a calculator. Okay, let's try to simplify this fraction to make our lives easier. I could divide them by an equivalent form of 1. 2 would work, 4 would work, but you know what? I'm thinking, let's see, 8 would work as well. 16 would be too big for this one, but 8 works nicely. So if I divide by 1, 64 divided by 8, that would become 8. 24 divided by 8 would be 3. 8/3, so much easier. Okay, and I'm going to solve for this x here, so I'm just going to cross multiply. Again, I've got a proportion that can cross multiply. 21 times 8 equals, and again, a mistake people might make is just going 3 times 21 plus x without remembering it's the quantity. You have to put the parentheses there. Okay, let's do this without a calculator. 21 times 8, well, 20 times 8. 20 times 8 is like 2 times 8, that's like 16. So 20 times 8 is 160. 160 plus one more 8, right? 1 times 8 is 8. So 160 plus 8 is 168. Right? 168. 3 times 21, right? 3 times 20 is 60. 3 times 1 is 3. So 63. So 63 plus, don't forget, distribute here, not x, 3x. So to finish off, I just take 168 minus 63. So I'm out of space here, so I'm going to minus 63 on both sides. So 168 minus 63, that's going to give me 105 equals 3x. Divide both sides by 3. We can kind of guess and check here. Well, you don't have to do it this way, of course. You could do long division, but I want to divide this by 3 in my head. I don't know what this is, but you know what? I know that 90 divided by 3 is 30. That's pretty easy. And let's see, 90 plus what gives me to 105? 10 more gives me 100. 5 more gives me 105, so that'd be 15 more, right? So if I think about it, I could write 105 over 3 as 90 over 3 plus 15 over 3. I know 90 over 3 is 30. I know 15 over 3 is 5. This is 30 plus 5, so x must be 35. Right, so what was that? JE must be 35. Right, and you can double check that, but you know, the long, you know, this is probably harder to do. If you don't have a calculator, it's good to reduce it down and you know, use your head whenever you can. All right, we are done with today's lesson. No vocab or theorems for today's lesson.